In this video, we're going to look at a couple more examples of solving rational inequalities. And the first one we have here is 1 over x minus 3 is less than or equal to 9 over 4x plus 3. Once again, the first step is we want to set the inequality to 0. So if we do that, we're simply going to subtract the 9 over 4x plus 3 so that we have this less than or equal to 0. And just like we did with the example in the previous video, we needed to combine this into one expression. So in order to subtract, we need to find a common denominator, and the least common denominator is going to be the x minus 3 and 4x plus 3. So the first part here, we have 1 over x minus 3. So we need to multiply the bottom by 4x plus 3 and the top by 4x plus 3. Minus, and then we have 9 over, once again here, we actually have the 4x plus 3. So therefore, we need to multiply by the x minus 3. So now that we have our common denominator, we're going to simplify the numerator here. So 1 times 4x plus 3 is simply 4x plus 3. And once again, as I distribute, I'm going to distribute the negative 9 to the x and to the negative 3. So that's going to give you a negative 9x. And 2 negatives will give you a positive 27, and this is all over the common denominator of x minus 3 and 4x plus 3. And then if we continue to simplify the numerator, 4x minus 9x would be a negative 5x, and 3 and 27 is 30. And now we have our inequality simplified to where we have over here on the left, we have this one expression equal to 0. So now, just like that we did before, we need to identify what is going to be, what are the zeros. So what's going to make this rational expression equal to 0? Well, just like before, all we have to do is take the numerator, negative 5x plus 30, and set that equal to 0. So negative 5x is equal to negative 30 divided by negative 5, so x is equal to a positive 6. And then we need to figure out where is this expression undefined. And once again, we simply take the denominator, x minus 3, 4x plus 3, and set that equal to 0. So x minus 3, set that equal to 0, so that means x is 3. And we take the factor 4x plus 3, we set that equal to 0. So 4x is equal to a negative 3, which means x is equal to a negative 3/4. So we've identified the zeros and where the function is undefined. So now we can find the test intervals. And once again, we're going to start from negative infinity. And we have what our smallest number here is the negative 3/4. And then we're going to continue from a negative 3/4 to 3, from 3 to 6, and then from 6 to infinity. So once again, we now need to pick our test values. So if we identify our numbers within the particular intervals, and again, I'm going to pick the smallest one, -1, 0, 4, and 7. And we're going to test this in, I'll copy this down, the -5x plus 30 over the x minus 3, 4x plus 3. And once again, I'll use the calculator to help with this. So we go to y equals, and again, we want parentheses around the numerator, which is a -5x plus 30. Close the parentheses, and this is divided by, and I'm going to put parentheses for the entire denominator and then parentheses for the factor, which was the x minus 3, and then parentheses around the factor 4x plus 3, and then I need another set of parentheses for the entire denominator. So then if we go to the table, we can delete the previous values and now plug in the test values of -1, 0, 4, and 7. -1, whoops, -1, 0, 4, and 7. So I'm going to record the values here. We have 8.75, negative, I'll round it 3.3, and 0.526, and we had a -0.04. And once again, we're really concerned with, as far as what conclusion we're looking for here, is negative or positive. So we obviously have a positive, negative, positive, and negative. So in order to then identify the solution, make sure that you look at the inequality again, and keep in mind we're looking at where this is less than or equal to 0. So that means we're looking at where it's going to be negative. So that's here and here. So that's a -3/4 to 3, and from 6 to infinity. And we need to again, and maybe if you didn't already, pause the video and see if you can come up with the correct solution with the correct parentheses and brackets needed for the intervals. So we know we're going from -3/4 to 3, and we know we're going from 6 to infinity. And of course, infinity always has parentheses. So the question is now, for the -3/4, is the -3/4 part of the solution? Well, if we go up here and look, the -3/4 is what makes the inequality undefined. So therefore, we would have to use parentheses. The +3, well, the +3 is also where the inequality is undefined. So again, we would use parentheses. And for the 6 is what makes the rational expression 0, which it says we can be less than or equal to 0. So that means 0 is less than or equal to 0. So 6 would be part of the solution with a bracket. So this would be the answer here. Negative 3/4 to 3 or 6 to infinity. Okay? And once again, if you want to look at this on a number line as far as the solution, you would simply locate 3, negative 3/4. We would have parentheses and highlight between, and we would identify 6 with a bracket and go towards infinity. And if we want to verify this, once again, we can always look at the graph. Is the graph of this rational inequality, is it below the x-axis within the two intervals? So if we go here and we hit graph, we can see that the function is below, what did we say it was? Negative 3/4 to 3. Well, this is about a negative 3/4 here, all the way up to 1, 2, 3. And again, this goes down and the graph splits because we have a vertical asymptote. So all the way to 3, and then from 6 to infinity, so 1, 2, 3, 4, 5, 6. So right here at 6, this graph then remains below the x-axis. So that verifies that this is the correct solution. All right, let's look at one more example. And this will be x squared plus x minus 6 divided by x is greater than or equal to 0. Well, to start out, once again, we want to make sure that it is set to 0, which that is already done for us. So all we need to do is identify the zeros, and we can simply take the numerator, x squared plus x minus 6, set it equal to 0 and solve. So we can factor the trinomial, x and x. And what are we going to factor for 6? We have 1 and 6 and 2 and 3. And it looks like we could go 3 times 2 is 6 with a positive 3 and a negative 2. So therefore, x would be equal to a negative 3 and x would be equal to positive 2. And then if we want to look at where the inequality is undefined, the denominator is simply x, so that's easy enough. If x is 0, then we have division by 0, so that's going to make it undefined. So again, we're going to use those 3 points to set up our test intervals. So again, we're going to start with negative infinity, and we'll go up to negative 3. From negative 3, we go to 0, and then from 0 to 2, and from 2 to infinity. Next, we want to pick our test values. And again, I picked the smallest that we can, so negative 4, negative 2, 1, and 3. In this case, what are we trying to test? We want to find out what is the value of this expression. So it's x squared plus x minus 6 over x. So that's what we want to test the values in. So once again, if I go to the calculator, we can type in parentheses x squared plus x minus 6, close parentheses, divided by simply x. And if we go into the table, let me delete out the old values. And we want to plug in negative 4, negative 2, 1, and 3. So negative 4, negative 2, 1, and 3. So negative 1.5, 2, negative 4, and 2. So negative 1.5, positive 2, negative 4, and a positive 2. So what's the conclusion? We end up with negative, positive, negative, positive. So in order to identify the solution, once again, what are we looking at here for the solution? Now we're looking at where is this greater than or equal to 0. So that means we're looking for positive values, which would be from negative 3 to 0 and from 2 to infinity. Now, once again, are you able to correctly label the brackets and parentheses? Well, we know we're going from negative 3 to 0 and from 2 to infinity. So if we check a negative 3 is what makes the inequality here 0, and it says that it can be greater than or equal to 0. So therefore, the negative 3 is a solution. Now, the 0 is where we're undefined, so that means that is not part of the solution, so we would use parentheses. And if we check on the 2, once again, the 2 is where we get a 0, so that would mean we would use a bracket on the 2. So negative 3 to 0 or from 2 to infinity. And again here, this should be parentheses on the 0. So this is our solution for this rational inequality. And once again, if we wanted to demonstrate this solution on the number line, you would simply have negative 3, 0, a bracket on 3, parentheses on 0 in between those two, and then a bracket on 2 going to the right to positive infinity. So hopefully now you have a better understanding of from the previous videos with solving polynomial inequalities and now solving rational inequalities.